Okay, these three angles total 180. So therefore, how many x's are here altogether?
3.
3, 6, 7. 3, 6, 7 x's. So that makes 7x equal to 180. Doesn't it? And then you just solve that. Okay, this is 90. So 90 plus 2x is equal to 180. And you solve that very simply. All right, this is 90 equals 40 plus 6x plus 2. And then this is simply 2 plus 3x equals 62. And so this, when we subtract the 2, 3x equals 60. This is x equals 20. This one is 50. Subtract 2 is 48. X equals 8. This one, subtract 90, and this is 45, equals x. 7 goes into this 2 times. That's 40, which is 5 and 5/7. Maybe you're right. Oh no, this is interesting. This is 3x, and this is 3x. That means these are 45-degree angles. So this is 3x equals 90. Oh, I know why. But this is 6, not 7. Three, 4, 5, 6. I double that. Okay. All right. Okay. Now, all right. I want you to put your name on that paper. And I'm going to collect it. And now we're going to go to part 1. Is this thing on? I hope.
Got it.
Yes.
The red light's blinking.
Yes. What?
The red light is blinking.
Yes. Okay. All right. Now.
Wait, what?
All right. All right, now, what I've passed out to you is, I've got to get on this side, be able to work this now. We're going to start on chapter 2, so I can kill this. All right, and I've got, this is your tiling thing here. What they're asking you to do is to determine on these particular shapes what will tile the grid here. Now, obviously, if you had small boxes, like there's 1, 2, 3, 4, there's 5 small boxes in this shape. Can you see it? 4 on the outside and 1 in the center, right? So if you took these and you set them here and here, you try to determine whether or not you can cover all of this without overlapping or leaving gaps. All right, in which case, this would be called a tessellation. And so if you use this, which is made up of 2 squares in a row, and I'm sorry, maybe 3, that looks like the same height. All right, could you put those in here and cover all of these shapes if you had enough of them? The answer is probably yes. All right, and so then the question is, will these others, will this work? I don't know, you have to find out. All right, and that's why you have this card stock, to try to find that out. Okay, now.
We're actually cutting these out.
Yes, yeah, you're gonna have to figure that part out. Okay, now I'm gonna try to get. All right, don't. You can do that. You can do that at a different time. All right, because we're a little bit behind, so I'm gonna move ahead if I can find my geometry. There it is. Okay. What I'm going to do here is I'm going to get to the textbook and we're going to talk about these pages, just like we did last time. All right, so I got to go here. All right, chapter 2. Okay. All right. So the first thing we're going to do is look at some definitions. All right. The line over top of 2 letters is for a line segment. All right. So in this case, AB are the ends of the line, and the fact that it's a line has a straight line across it, no dots on the top of it. But it means the dot at A and the dot at B and the straight line in between, so it's a line segment. But the symbol has no dots at the end of the little line over top of it. Okay, so that's the first thing. All right, second definition is definition of a polygon. A polygon is a closed figure that's made of line segments. All right, closed figure, so you can't have an opening, and it's made of line segments. Now, this end here, in fact, draw this on your paper really quickly, and I'm going to give you a couple of other definitions. All right, obviously, vertex is a point where 2 lines meet, right? And a side, that kind of makes sense. But right here in this little blank area, write the word concave, C-O-N-C-A-V-E. This is a concave relationship. And as long as this vertex that I'm pointing at, as long as it doesn't touch or cross another line, another side, then it's still considered a polygon. If this were coming up instead of in, it would be convex. But because it's dropped in, it's concave. We don't see in normal, regular polygons, you will not see a concave part. But they can exist. Okay? So we have segment, vertex, side, concave. All right, now let me see if I can figure out how to move up. Oh, why? What's wrong?
Page over.
Huh? Oh, page over. Thank you. I didn't see that. Okay? All right, now, polygons. All right, we used to do this in 8th grade where they numbered 1 through 10. 1 was a segment, 2 was an angle, because if you took 2 segments and added them together, you would have an angle. And then above that, you have a polygon. So 3-sided figure, we all know, triangle, 4 quadrilateral, then pentagon, hexagon, heptagon, octagon, nonagon, decagon. So add the 9 and 10. 9, if you put in your notes, is an N-O-N-A-G-O-N, nonagon. That's a 9-sided figure. A 10-sided figure is like decimal, it's a decagon, D-E-C-A-G-O-N. So what is 1? 1 is a segment. 2 is an angle. Right? And where the angles meet is called a vertex. That was our vocabulary word. And then triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. That's 1 through 10. Okay? Now, they're asking for a 5-gon or a pentagon which tiles a plane. Okay, so the question is, does a regular pentagon, will it meet together and tile a plane? Okay, now let's look at that for a second. All right. In fact, I'm going to put okay. All right. There's 6. All right, here's the pentagon. And those pentagons of that shape will tile the board. All right, if you look at this one, this is a regular pentagon. A regular pentagon will not. Because there's the sides, the way that they angle out, there will be a blank here. But this particular shaped pentagon will tile the board. All right, there's another one, similar shape. There's a pentagon. All right, these are called tessellations, and you can do them with different side figures. And even if you have some blanks, I think this is a decagon. I think it's a 10-sided figure, and it has some little shapes. But look at that shape. See that like hourglass? You notice all of these are the same hourglass shape? Because each time you bring these together consistently, they all produce the same surface area, and so there's the same amount of area left over. All right, that's part of what we're looking at here. Okay, now I go back here. All right. So, all right, now some of the things that we already know. Some of angles of a triangle, 180, not new, right? And then what are parallel lines? Now, parallel lines are 2 straight lines that are always the same distance apart. They never intersect. Now, with my 8th grader, he had to write the symbol for parallel. You know what the symbol for parallel is? The symbol for parallel, it looks like an 11 except it's bigger, but it's two straight lines. So if this says M and L, right? M and L are parallel. So if we were to draw that, in the drawing, we would get what you see there. But if you wanted to do that, you would say L is parallel with M. And it looks like it's 11, but it's just a little bit larger than the number. If it was perpendicular, you would say L upside down T is perpendicular with N. And that would give you a line of N coming here to the right angle. Now I know that you know parallel and perpendicular, but those are the symbols for it, which you may not have had in the past. All right, now, when we get two parallel lines, now this was very nice. In the book, they labeled that crossing line with a T. Because this word, the word for this line is transversal. Transversal. All right, that's a vocabulary word you better know. It's a really important. All right, and in the transversal, what we're going to have is relationships of those 8 angles. All right, and that's the first thing that we're going to talk about here in this chapter. Okay, and they're telling you to measure them, to observe it. If L is parallel with M, then corresponding angles. So that becomes our first vocabulary word. And I think I had a, hang on a minute. Is it here? Yeah. Okay. All right. Corresponding angles are two angles are corresponding when they have corresponding positions. All right, that means they're in the same location. And the easiest way to figure that out is to look at each intersection. Because this transversal is crossing the set of parallel lines. So we have a vertex here, and we have a vertex here. Okay, where is the blue angle in that first drawing? How would you describe it? Is it in the upper right-hand corner of the intersection?
Yeah.
Okay, all right. If it is a corresponding position, it's the same location in the other intersection. So if this is in the upper right, the corresponding angle is also in the upper right. If this is in the lower left, then the corresponding angle will be the green one in the lower left of the other intersection. Those are corresponding, and those values are the same. Just like when we had in the first one that the angle from B to P and from B prime to P was the same value. All right, this angle and this angle is the same value. Now, alternate interior are doing what it says. They're alternating on either side of the transversal, and they're interior inside the parallel lines. And when we were in 8th grade, and I was teaching this in 8th grade, the first thing they'd have to do is shade in the parallel lines. And the interior angles are in the shaded area in between the two lines. The exterior are not in the shaded area. So, but to be alternating If this is on the right side, alternating means the other one's on the left side. So they're alternating either side of the transversal. And so if they're interior and alternating, they're there, or the other pair. If they're exterior and alternating, the exterior alternating angle with this one is down here. It has to be outside and on the other side of the transversal. All right, so where do you find corresponding angles? Same place, different intersection. Say it. Same place, different intersections, corresponding. All right, alternating, how do you find those? They're on
opposite sides of the transversal.
very good, opposite sides of the transversal. Okay, and then so alternating interior and alternating exterior. Okay, now, all right, corresponding angles are congruent, so that means 65 is equal to 2x minus 3. And you can solve for x. Okay? This value is 65 because it corresponds with this one. Now, what is the alternating exterior angle with 65? Alternating exterior will be up here. It's also 65. So, alternating interior with this 2x one is right here, where my finger is. And so, these two are vertical angles, and so I have 1, 2, 3, 4 angles, all the same value. That's 65, okay? What's left? If this is 180, that makes that one 115. This is 115, the corresponding angle, this is 115. The vertical angle, that's 115. The alternating exterior, that's 115. So in that particular situation, you have two angle measurements. There are 4 measurements that are just alike, and there's another 4 that are just alike. And the two that add up together, because they're adjacent, add up to 180. Okay? Right now, what I do is I give this. That's 115. Where are the other 115-degree angles? Okay? Where's the corresponding angle with this? Right here. Where's the alternating exterior with this? It's up here. Now, if you understand the definitions, you have to label it that way, even though it doesn't look like it's right. Okay, and that's the way I keep people from guessing the big angle and the little angle. Right? Is I write not to scale, and I'll mislabel the small one with the big dimension, and then you've got to go ahead and do that. But if I told you that this one was 120 degrees, and this one was 60 degrees, do they add up to 180?
Yes.
So therefore, they can be right, but it doesn't look like it based on the picture. And so you just write, not to scale. Which means you can't go by how it looks, you have to go by. You do the same thing with the right angle. Is that a right angle?
No.
Yes, it is. Why is it a right angle?
This is the box.
Because of the box, right? The box. Now, is it drawn well?
No.
Not drawn well at all. But what is this? Is that a right angle?
No.
Or is that 91.2 degrees? 89.7 degrees. See, you don't know. This one we know it's drawn very poorly, but this is still 90 degrees because of the box. And that's the point, is that if I give you a measurement in a drawing like this, you know the corresponding angles have to be the same. The alternating exterior and the alternating interior have to be the same, whether or not it's a good drawing or a bad drawing. Okay? Now, what happens if they're on the same side? We said the alternating are equal, congruent. If they're on the same side, they are supplementary. They add up to 180. So this angle and this angle add up to 180. Because they are same side where? Interior or exterior? Interior. Same side interior, right? The same side exterior would also add up to 180. So alternating is congruent and same side is supplementary. Okay? All right, now we can go back, hopefully. Wow, that's weird. All right, so now let's look at this. All right, why is angle 1 equal with angle 3? What relationship does angle 1 have with angle 3? Starts with a C.
Congruent.
No, well, they are congruent, but that's not the relationship. They're corresponding. All right, what is the relationship with angle 1 and angle 2? First, where are they located?
Corresponding.
No, they're not corresponding. 1 and 3 are corresponding.
Parallel. Interior.
They're interior, they're alternating interior, so they are equal because 1 and 2 are alternating. Now, what is the name or relationship between 2 and 3? Starts with a V. Vertical. 2 and 3 are vertical, 1 and 3 are corresponding, and 1 and 2 are alternating interior. Now, where do you find the alternating exterior with 3? Where's the alternating exterior with 3?
Opposite T.
Has to be where my cursor is.
Back there. Back.
Right? Because it's outside the parallel lines and it's on the other side of the transversal from 3. And therefore, 1, 2, 3, and the cursor are all the same value. And then what they're saying here in C is if 1 and 3 are corresponding and they're congruent, and then 3 and 2 are vertical, then they're congruent, and that means then that the alternating interior also have to be congruent because the transitive property says if 1 is equal to 2 and 2 is equal to 3, then 1 is equal to 3. Okay? Now, so now we have this right here. All right, let's see. Kayla, name a pair of corresponding angles in this drawing. Corresponding. Corresponding means what? Same place, but different intersection. 1 and 3 are vertical. This is one intersection, this is the other intersection. So where is 1 located in this top intersection? Lower right. Where's the lower right in this intersection? 5. So 1 and 5 are corresponding. All right, Bennett, give me another one. Corresponding.
6 and 2.
6 is lower left and 2. Good. All right, Case?
3 and 7.
3 and 7. 3 and 7. All right, and the last one? 4 and 8. And they're all what? Corresponding. Okay? All right, so now we're down to this one. Name the corresponding angles in A. 58 and Y, yep.
WS.
WS, X and U,
VR.
and V and R. Okay, now, which of them will be 58 degrees?
U. No.
Y.
Y.
Y
R.
Wait.
and
Y.
58
R and
R and
V.
V, because see, Y and R are alternating exterior, right? R and V are corresponding, right? And so 58 R, V, and Y are all 58 degrees. Now, how would you find the value of the other one?
Take 58.
Take 180 and subtract 58. Yeah. Okay. Now,
122.
all right, that may be what they did here. Yeah, it is, because that's the same number. I would use a different number. But at any rate,
No,
X, Y, W, V.
I think it is a different number.
All right, now all they did was just turned it. They just turned it.
Wouldn't it be 122?
Well, if I had 50, then you're right. It would be. Yes, never mind. Okay, they didn't do it. It's 48, not 58. Okay, so the same thing. Now, okay, so this is, X is exterior, right? Where's the alternating exterior?
R.
R, okay? They're both 48 degrees. Okay, now, U and Y add up to 180. Y is in the corresponding position, so it is 132. U is 48. Okay? All right, now what are we doing here? All right, next page. Okay. All right, now, all right, this is a classic problem. Do you see the parallel lines? You see the parallel lines, okay? There are two transversals. Now here's what I want you to do. In your notes, draw those parallel lines, L and M. And then the two lines, let them extend beyond to the exterior. Extend this line so that you get the exterior. And I'm going to do it on the board to show you what I mean. Okay, now, with this first transversal, and we're going to call this L1, let me call it T1 for transversal. That's T1, and this is T2. Okay, for T1, where do you find the corresponding angle with 2? The corresponding angle with 2 is here, and the corresponding angle with 2 is there. Because you have to use the parallel lines and only the T1 transversal. Now, angle 1 is up here. That's angle 1. The corresponding angle, angle 1. Now, this is interior. This is alternating interior. So 2 and 7 are congruent. Now let's come the other way. Let's look at this one. 3 and 5 are alternating interior. 4 and 6 plus 7 are corresponding. I'm sorry, are alternating interior. 4 is the same as 6 plus 7, if we didn't have this line here. So this 4 is the same as 6 plus 7. All right, now, let me just tell you something. What I do in my 8th grade class is I do this. And we number every one of the angles, and I would give them, let's say, this is 82, and this one is 121. And I want to know is, what's that angle there? Okay. If this is 82, what do you know about this angle?
82.
It's 82. If this is 82, what about that angle?
82.
All right, and if that's 82, what about that angle?
82.
Okay. All right, now, do the same thing. How do I find this angle? Use different skill. Is it a straight line?
59.
Huh?
59.
59. So this is 59. Then what about this angle?
59.
And what about that angle?
59.
What about that angle?
59.
So I have 59 here, and I have 82 here. Subtract them from 180, you get the top. All right, so 180, subtract those, it looks like it's going to be about 47 degrees.
39.
Huh?
39.
39? Okay, so, but that's, you used to have 8th graders doing that. And all it's doing is using these skills and these definitions. Okay, now let's look at this one. All right, it says, let A be a triangle, let B be a line through C that's parallel with the opposite side. That means these two are parallel. What is true about angle 1 and angle 4?
Angle 1 and angle 4. They are opposite.
All right, I'm going to draw this way.
Opposite interior angles.
Right, they're alternating interior angles, so they're congruent. All right, what about 3 and 5?
They're the same.
They're saying they're alternating interior with the other transversal.
I'm slowly pushing the table out too.
All right, and so that means that if 5 plus 2 plus 4 equal 180 because it's a straight line, then 1 plus 2 plus 3 equals 180, and the same number of degrees in a triangle also occur in a straight line. They're both 180 degrees. And that's what that's showing. All right, now let me see if I can. Oh, come on. There it is. Okay. Let come back on. I'm going to bring a different extension cord so we can get these things out of the way.
Bingo.
All right, is it up?
Kind of.
Okay.
Slowly.
Okay, so if the 3 angles of a triangle all add up to 180, then A, B, and C shouldn't be that big a problem, right? Okay, now, this one, X, is called an exterior angle. Right? X is called an exterior angle, and there's a postulate that says that because this plus 85 equals 180, and 60 plus 35 plus 85 equals 180, then X has to be the same as 60 plus 35, 95 degrees. Right? The value of the exterior angle is the same as the sum of the remote angles, because this is the adjacent and these are remote. So how do we get this value of X? We add these two numbers. Because these two numbers plus whatever this missing one is 180. X plus this missing one is 180. So X has to equal both of those. So then what happens in C? What is the value of X?
125. 125.
Yes, I just add them together. And here, what's the value of X? 40. Okay. All right, now, what's the value of X here?
A plus B.
Very good, very good. You're right. Say it again, Casey.
A plus B.
A plus B. How do you get that? These are the two remote angles, so they have to be added together. Okay, and that's what you'll find in that part. Oh. All right, I don't have to go over obtuse and acute angles with you, I hope not.
No.
All right, okay, that won't be a problem then. All right, now the other thing that's important, all right, in this bottom part, how many triangles were created by taking lines from one vertex to all the other vertexes? How many lines were created? How many triangles?
3.
3. How many degrees in each triangle?
180.
So therefore, 3 times 180 is the total of the degrees in this whole figure. Okay? It is this side and the bottom side are not counted. And so n minus 2 times 180. So if n is 6, you're going to have 4 times 180 degrees. If n is 1,000, you're going to have 998 times 180 degrees in each angle there. N minus 2 times 180. All right, almost done. Okay, that's it. That's the summary. Okay, so I want you to work through that. The tiling exhibition is supposed to be there. Now, the other thing that we didn't get to today is projects. I am going to send you the list of where the projects come from. Let's see if I here. I don't have them on this one. I've run out of time, haven't I? I left those papers at home with my property. All right, let's see. Yeah, here it is. Okay. Okay. You're going to do a group project. Because we have 4, what we're going to do is do a group project with 2 of you together. And then Chase is going to have to do his at home by himself. So he'll have 1 in his group. All right. The group project is your choice of these projects that are listed in the book. Project 3 from page 22, or project 2, 8, 9, or 10 from 60 to 62. You and your partner agree on one of those projects. And then you're going to have to meet outside of class to get the project done. And then there's a rubric that grades partner participation, and there's also a grading rubric to see what your grade is going to be. Okay, so I'm hoping that you'll be able to either during study hall here, or you can get together outside of class. You've got to be able to get the project done, I think by week 5. This is week 2, so you got like 3 weeks. But I'll put this on the teacher page and send, no, I'll send it to you too. All right, but that's the project that you're going to choose. Now, is it okay to work this way, or do you want to work boys, girls, and girls? Okay, boys and girls. Fine, no problem. Okay, the guys and the girls. So, all right, so you have to, listen, you have to decide what project you're going to work on, and then plan who's going to do what. So that you both can give each other decent grades as far as being partners. That's one rubric, and then the grading rubric is the other. Okay? All right, thank you. In fact, it's 40, so that is perfect timing. All right, have a good day, and God bless you.